Good afternoon. I'm going to introduce the speakers. Nahuel, you will begin, right? Nahuel, who is an agronomer and a doctor in agricultural sciences from the University of Mar del Plata. He is an independent researcher at CONICET. He is a professor in the School of Agricultural Sciences, and he has collaborated in different universities. He is an associate editor of the magazine Ciencia del Suelo, and he is a consultant for different companies and Aapresid. He has several national and international publications to do with soil fertility and crop nutrition. The other speaker is Nicolás Wyngaard. He is also an agronomer, master in vegetable production, and has a doctorate in soils and crops. He teaches at the National University in Mar del Plata. He is a CONICET researcher. He researches the changes generated by the use and management of the soil on biological, chemical, and physical variables that impact directly on its fertility. Thank you.
Buenos días.
Good afternoon, everybody. How are you doing? The idea here with Nicolás is, if possible, to have a short presentation on what we understand is our perspective on the role of fertility to bridge gaps when it comes to yield. And the proposal for today is to first speak about the current context, and secondly, to show our current position when it comes to bridging the gap, how we measure, etc. The third point is what we like to mention, which is that information kills off fakeness, and some final considerations as well. What is the current context? As you have heard in many of today's workshops, what we know right now, we have a gap in yield in crops in the Pampas region that oscillate from 30 to 50% according to the conditions, the climate, etc. This means that the producer misses out between 30 and 50% of the yield that they could have in the right conditions. I'm sure that you say, I don't have that gap in my crops, but take into account that in the Pampas, this is the gap, which means that we've got a lot to gain. And with that, nutrition is key. And in general terms, the handling or a balanced nutrition helps us to account for 50% of that gap. That means that if we do a diagnosis and we correct that diagnosis on the basis of a balanced nutrition, we could get rid of 50% of the gap we have. Clearly, not everything is up to nutrition. But what are the implications if we take any type of crop? What are the implications? What is the impact of a balanced nutrition on crops? And what we show here is that if we take the average performance, which is about 7,600 kilos, the average that we could aspire to, it would be 11,500, so we could gain about 4,000 kilos. And in order to build that additional yield, we need clearly to have more nutrients on our system. Any which way you want it, but we need to have more nutrients. Nitrogen, that is the example here. Phosphorus is 22 kilos additionally. And if we put figures on it or costs on it, and if we do calculations on analysis, this is about a gain or a result of about $500 per hectare for a balanced nutrition in order to close that gap. If we take it to the surface in the Pampas region and we say, let us just do this closing of this gap in a third of these hectares, that is $1 billion. And corn is just 32% of the area. So that is the magnitude of the problem we're facing when it comes to the yield gap in corn. So this is the context. You may say, where are we today? And this is our position at the moment. We are a bit blind. Why? Because as you know, we take a sample every 300 or 400 hectares in the Pampas, and that means if we extrapolate from corn is that we fertilize over 90% of the corn that is sowed in Argentina, almost 8 million hectares. We fertilize over 90%, but we only sample 30% of those areas. And the producer, you invest $200 in fertilizer, you choose the best hybrid, which is about $200 in seed, but they don't know where the starting point is, and we want to produce more grain. And of course, all fields, if any of you have gone down to Venado Tuerto, all of the fields, we think that it's the tables that come out from Venado Tuerto. We don't know the variability. That is the second problem we have. We think that all fields are equal, and we don't have data to make decisions. And it's not to do with cost, because if we put it by cost per hectare to take the analysis of soil, it may even be $5, $6 per hectare that we must invest in the sampling of the soil, when actually we spend $200 in fertilizer or seeds in the case of corn. So that is the reality. We have a gap in yield. We want to produce more grain. We know that nutrition is key, but we don't have data to be able to make decisions. Many have data to put it on an Excel form, but then they don't translate it into reality. So I have bad news, because you can always be in a worse position. This is the situation, but things can always be worse. And I'm going to ask Nicolás now to tell us a bit about, from the availability of nutrients in the Pampas region. Are we better or are we worse? Good afternoon. The key of the question is what Nahuel mentioned, which is availability of nutrients. Nahuel has spoken about the yield gap, which is the difference between the optimum yield that is reachable and the real yield. He's telling us that part of this gap is accounted for by nutrients, and it is explained by the difference between the requirement for nutrients that the crop has and what the soil can give us, the availability of nutrients. So in this part of the presentation, what I will show you is the maps that evaluate the availability of nutrients in the Pampas region that were done and led by Hernán Sáez Rosas. So these maps is something that you will link to Hernán, and I'm going to show you the updated version. How am I going to divide this part of the presentation? In these nutrients, which are the limiting factors for production in the Pampas, and I'm going to divide it among non-mobile or barely mobile nutrients and mobile nutrients. Some of you will have some doubts with boron, which can be mobile or not. Logistically, I like to put it as not very mobile. It's boron, but I could have put it in the other column. So we will begin with phosphorus. You can see a soil that is pristine or pseudo-virgin. In the Pampas, it's very hard to find this type of soil to put it as a reference. So these are soils that are close to the pristine nature. So this is by doing multiple samples, the different conditions in each of those points. As I said, on the right, you have the pristine soil. You see that most of the values are green. You can see phosphorus levels of 20 parts per million upwards. Is that a lot? Is that too little? Let us focus on the categories of what the different crops need of these nutrients. And let us take a referral value of 16. Let's put it on a critical threshold of 16. If I have from 16 parts per million upwards, the yield of the crops won't be affected. If I have 16 and lower, it will be affected. And if this is affected, there is a gap. So there is low availability, and then there is a gap in yield. And what I did for the pristine soil is to see what the proportion of the points that we sample is below the level of 16 ppm. And for virgin or pristine soils, we can see that it was 16%. We moved forward 20 to 28 in agricultural soils, and that is 42%. What is this telling us? That in 42% of the surface of the Pampas, phosphorus is the cause of the yield gap. We go to potassium. This is the map for potassium. The totally green area. Where do we see yellow? In Entre Rios, the province of Entre Rios. The pristine soil extends, the values fall, but where do they fall the most? Once again, in Entre Rios, because the material that gave origin to these soils is poor in potassium, and it is very similar to the soils in Uruguay. That's why in Uruguay there is a deficiency of potassium, the same as in Entre Rios. Let us see the threshold for the Pampas region. This was done by Oscar Avila, and we're talking about 218 ppm. Over that is sufficient. Lower, there is a gap or deficiency. And what is the proportion of the sampling areas that have values below this in pristine soils? Less than 1%. Low. What proportion do those values have in 2024? 5%. And you could tell us, Nico, we're not doing so badly with potassium. The thing is that if I focus here, if I go to Entre Rios, that proportion is 20%. So this speaks to us a bit about how the analysis can change the perspective, but it depends on where. We will now go to the first of micronutrients that will limit production, zinc. This is one of my favorite maps because you can see the difference clearly. Pristine soil, everything is in green, and you have colors when we transition to other ecosystems. What is the threshold for the Pampas? It depends on 1.18. If you check on the scale, below 118, it would be yellow, orange, or red. Those colors did not even figure in this. They appear more and more frequently. And what is the proportion of the sites that is below that in a virgin or pristine soil? 50%. How much do we have now? 56%. This is highly significant to say that 50% of the surface of the Pampas region will show a gap. We go now to boron. The threshold for boron is 0.78. The color is either orange or red in virgin soil that did not exist. Where does it appear when we transition to the ecosystem? Where do we see that the most efficient? In the red, it is in the core area, the north of the province of Buenos Aires. How many sites are underneath this? 3%, and now we are in 56% for boron, and that's very high. And with this, we will close up on the less mobile nutrients, and the question is, why are the levels of nutrients in soil going down? And this is pretty clear when we see this graph. I have the data for phosphorus and potassium, and I did not have it for zinc and boron, but now I do. In red, you can see the extraction of nutrients with grains. In blue, what we apply as fertilizers. It is the famous balance of nutrients, how much we export, how much we add. And that difference is negative, and that shows that we are taking out nutrients from the soil and not replenishing it. And replenishing it is valid because I can add nutrients, and beyond what the crop will take with it, nutrients may remain in the soil, and therefore I can reconstruct fertilization the levels of phosphorus, potassium, and zinc. Things are different when we speak about mobile nutrients such as nitrogen and sulfur. And here I have to go into the basic chemistry of these nutrients and separate them into inorganic and organic. The inorganic ones are highly mobile. For nitrogen is nitrate, for sulfate. And these are the ones that are available for plants. But these are highly mobile. And if I want a map, like phosphorus, I can take a sample of the soil, I determine the content of nitrate, and the next day, if it rains, the value is not the same because they are highly mobile. So I won't be able to present a map of availability of nitrogen and sulfur because it is like a picture, like an instant picture. I can measure it one day, and then the next day it's completely different. So I have to get into the organic forms, which represent most of the nitrogen and sulfur in the soil, which can be released and be available for crops. And these fractions are associated or linked to organic matter. What I'm saying here is that most of the sulfur and the nitrogen is in organic matter and potentially may be available for the crops. So if I want to speak about the availability for these two, I have to show you the map of organic matter. More organic matter, more stock of nitrogen and sulfur that is organic that potentially could be available for crops. The average values for the Pampas region in virgin soils was 4.3, and now we are at 3.1. You could say that doesn't seem so tragic, but you must see at what region we're looking at within the Pampas, because if we focus in Entre Rios and the southeast of the province of Buenos Aires is where changes were larger. The higher falls were seen in soils that had more organic matter to begin with. How much does this represent in nitrogen and sulfur? I'm going to show you an estimation that we did for corn, which indicates a fall of 1% of the content of organic matter represents a fall in the availability of nitrogen that in order to be subsidized through applying fertilizers means a cost of $96 per hectare. And this is the price of the loss of organic matter, just thinking about nitrogen and just thinking about corn. Once again, I can do a balance of nutrients for nitrogen and sulfur, how much is added, how much we take from it. Once again, the balance gives me a negative figure. And I can say I want to up the level of nitrogen in the soil, so I fertilize, but this is mobile nutrient, so it's not valid. and then I fertilize with nitrogen and sulfur, yes, logically, I can fertilize with that. Why? Because I have to replace the demand of the crop at a given time, and I have to close that particular gap. But if I fertilize with nitrogen and sulfur, will I improve the stock of sulfur and nitrogen in the soil? It won't accumulate because it's mobile. If the crop doesn't take it, it'll get lost.
So what do I do if I want to increase the nitrogen and sulfur stock? I need to increase the organic matter content. I have been talking about nutrients. Is nutrition all that matters? Now, to conclude what we wanted to mention with Nicolás and what we have seen in different workshops in this Congress, if we want to bridge the yield gap, what we know, based on studies, is that nutrition is one of the links in the chain. But it is not enough. With nutrition, if you can handle nitrogen in maize, we will not solve the crop rotation problems or soil management problems. Let's not forget that. We may be very good at handling nitrogen, but not so good at handling some other things. So we need to understand the full scope of the gap. If we manage the other links in the chain, nutrition will help us bridge the gap, the yield gap, and there is a lot of information from different areas showing this. Additionally, there's something else we should not forget. When you talk about soil fertility and crop nutrition, we tend to associate this with the chemical fertility of the soil. And the soil fertility has 3 dimensions that were also mentioned here. So we do have the chemical dimension, but we also have the physical and biological dimensions. If we do not measure the chemistry much, let's imagine how we can skip the other 2 dimensions. When I handle crop nutrition properly, there are even some crops that do not respond. And what was the problem? There was compacting of the surface. The fertility or the physical health of the soil is not the same as in the pristine condition or virgin condition of our region. We need to measure, we need to have data for decision making, but we should not forget the physical and biological dimensions. We need data for better decision-making, for closing the yield gap or the nutrients gap. But we wanted to conclude this panel with Nicolás with a message. Particularly, there are many miracle solutions that are proposed. But I wanted to share a reflection with you. There is a writer from the US who talked about the illiterate persons of the future. He said that illiterate persons in the future will not be those who cannot read or write. It will be those who cannot learn, unlearn, and based on evidence, learn again or relearn. And we are bringing this quote here for 2 reasons. One, we need data. We need to measure for better decision-making, but that data has to be backed by scientific evidence. It is very nice to hear a story, but we need to look at the data. The data without scientific evidence has no value. And secondly, we can have loads of data, but if we cannot change the chip, we cannot change the mindset of how we are producing. If we are not capable of unlearning what we have learned, it will be very difficult to close the gap in the nutrients and yields. This is a QR code. You will be able to access a platform of the Balcarce region. It is called Nutrienza, and it allows you to calculate nutrition based on science, driven by science. It is free of charge. You can access freely. If you have any questions, you can write to us, and we will try to help. Okay, you have data. Well, there are also platforms that allow you to make sense of that data to make better decisions. Thank you very much. Thank you for this presentation. We have some questions. The boron data, the threshold, what was the extractor that you used for that data? That's a good question. There are different extractors. The boron threshold that Nicolás showed is with hot water for soy and ammonium acetate for maize. There is overlapping. I would say that there are no big differences in the critical threshold. With any of the two extractors, you can use this threshold for interpretation. In the QR code in the platform, you will find the different reports, and you will find more information. So it is either hot water or ammonium acetate. There are two studies, one performed by Natalia Bustos from Córdoba for soy, and the other one, Pablo Barbieri's paper that determines the threshold for maize. So they have been loaded to that platform. Natalia Bustos' article has recently been published. It is freshly out of press. We have another question here, and you can also ask questions by asking for the mic. A crop with better nutrition in terms of nitrogen and sulfur, could it have better quality to improve organic matter in the soil? So a crop that has better nutrition in terms of nitrogen and sulfur, it will have better yield, but can it be also of better quality with more nitrogen and sulfur to improve the organic matter on the soil? Yes. It is very common to say that rastrojo is part of the organic matter. Rastrojo will have a better quality and better conditions for the next crop. It is a short-term effect. It is a decomposition of the leftover, but that leftover is not organic matter in the soil. Organic matter is particles of less than 2 millimeters. If we are talking about leftovers or residues of less than 2 millimeters, then it will be organic matter. Otherwise, it won't. It is real. If you conduct a diagnosis, it will allow you to have better conditions. This is not organic matter, but it may favor the building of organic matter with crops that have better nutrients. So we need to build or to fixate carbon in the soil, and we need nitrogen, phosphorus, sulfur, and all the nutrients associated with carbon. And there's something else. We can think about the residue as a temporary reservoir for nutrients. When you talk about building organic matter, we should consider the balance between input and output. That is the definition that is key for soil content. You can consider it from the perspective that you have more production, so I have more input of carbon in the soil. That addition of nitrogen in the soil will accelerate the microbial metabolism that will eat that residue, and it may also drive losses of organic matter. How about acidity in the soil? Loss of calcium. This is a very good question. With this presentation, we wanted to narrow down the scope so that we could have more time for discussion. So we looked at the nutrients that limit the crops. So we did not include pH, but there is acidification of the soil. There are several references, regional references. There is a study that will soon be published by Gaston Larrea, and there are significant drops of calcium and magnesium. Those drops in the acidification of the soils are associated with the base loss, calcium, magnesium, and potassium in the soils. If you re-fertilize maize in B6 with urea and calcium sulfate, will I be able to correct the deficiency, or are we too far ahead in the cycle? If sulfur is needed, well, the worst thing you can do is not to add sulfur. If you realize that you need sulfur, well, add sulfur, because sulfur has a return of 8 or 10 times to 1. For that sulfur to be absorbed, you need water. But please, add sulfur with the source that you deem best. I have a question. Soil fertility as a key to bridge the yield gap. What is the yield? The average, the national average. I am in the north center of the province of Buenos Aires. So we can have a gap that is specific for that region. When we have had peaks of 7,000 kilos in 2016, which is not normal. You talked about fertility, which is physical, chemical, and biological. The chemical fertility can be corrected with the contribution of nutrients. The physical can be built, can be destroyed, can be repaired with good management. And biological dimension, well, it is associated with good management based on the portfolio of nutrients. How long could it take us, for instance, in the core Pampas region in the north of Buenos Aires, how long would it take to take the status of soil or the condition of soils so that we can close the yield gap? Of course, we have the climate issues to consider. If we start doing things right to reach those nutrient levels, we do have the nutrients in some of the fields, but how do we deal with the floods, the droughts? How long? How many years? What would be the chronology to close the yield gap with that key? That's the important thing. That's the answer that we need from this presentation. I don't know if I have that key. If you came here to find an answer, well, it's complex. The question is very good, but the answer is complex. Let's look at the data and the experience in the southeast of Buenos Aires. You will never go back to the initial state of the soil. Whatever you do, it is very difficult to get the stability and the equilibrium of all those dimensions, the chemical, the physical, and the biological. How can we get close to it? In Balcarce, we have already studied this. It's 4 or 5 years of premium pastures. This will enable you to reach stabilization. However, we do not have cattle. So we know where we should be headed in order to restore fertility, chemical, physical, and biological. We have already studied it, but there are many advisors here, it's very difficult to put it in practice. So what we try to do is to define how to make up for it. And then we have different species, we have diversity, we can have some intermediate alternatives to mixed agriculture. That is as much as I can tell you. Thank you so much for the question. Yes, the terms are never short. Going back to what Nahuel was saying, he talked about pastures and also cover crops, not just in the southeast of Buenos Aires. In Cecilia Crespo's doctoral thesis, she evaluated after 10 years the effect of cover crops on the physical, chemical, and biological properties of the soil. Over those 10 years, in some sites of the Pampas, it was enough to improve organic matter, enzymatic activity, the aggregate stability. The values improved. However, they will never get near to the values of the virgin soil, the pristine soil. As Nahuel was saying, one thing is the climax, the final state of the virgin soil. And the other thing is the best case scenario we can reach with an agro-ecosystem. You were talking about timelines. In 10 years, we can see improvements in some sites, not in others, talking about fertilization. Yes, let me follow up on that. When we talk about yield gap, we don't necessarily go back to the pristine condition, because this has to do with what the genetics allow me to do. If I can achieve this with the green, light green or dark green colors, it's impossible to reach the pristine condition. That's not our goal, but we need to get as close as possible in the curve, defining the yield curve. We have measured sequential lots that were deteriorated over 5 and 6 years. When there is a rotation, which is very intensive with a high volume of plants, and there is a high content of leftovers, you achieve organic matter, the biological activity is also affected. The question is, would I be close or far away from that ideal condition with the 3 types of fertility to reach the maximum yields?
Bueno, una cosita, destaco algo que dijiste, que el hecho de que sea el suelo prístino no importa.
The thing is that if it is not pristine, it doesn't mean it will. If it is pristine, it also means there could be a gap. So those virgin soils are not necessarily indicators of having no deficiency. Pristine soils also may have deficiencies in nutrients. The gaps are estimated for the situations of production lots. There are no estimations for the initial conditions of those virgin soils. going back to a possible answer, it is not necessary to reach the condition to close the gap. And there are many companies that have closed the gap without going back to the pristine soils, which is impossible. Another question, is it true that sulfur interacts with nitrogen absorption? That is to say, if there is a deficiency of sulfur and I apply nitrogen, will the crop absorb it?
There is a strong interaction between nitrogen and sulfur, that's true, but the response is the other way around. If we have problems with sulfur, even if I add nitrogen, if I have problems with sulfur and I add, that sulfur doesn't only have the direct effect, but it improves the recovery of each kilo that I put in that system. So if I have troubles with sulfur, it's problems with sulfur. But if I correct sulfur, I improve nitrogen because the sulfur helps with the root systems. And as long as the compacting is not too bad. Another question, how long does urea nitrogen in its availability to the plant in the southeast in the current conditions? Around 15.2 hours, perhaps 15.3 hours. It depends on so many factors, actually. Urea, for the crop to take it, it needs to be hydrolyzed, and hydrolysis in normal conditions is produced in 1, 2, or 3 days, according, or maybe in the same day. So it is very variable, depends on many factors. The thing is that there's always the concept of the fact that I don't see the urea, so it's been incorporated already. And actually, many times you don't see the urea, and that means it dissolved, but it did not hydrolyze, because urea is soluble in water. But in order for it to become hydrolyzed, it depends on many factors, among them humidity. But if it has a temperature, for example, in a corn field, it can be in 1 day, the ammonium is taken by the crops. But if it has a colder temperature, it may take 3, 4 days. But don't think that hydrolysis in urea is a limiting factor for the availability of nitrogen from that source. If I'm going to put it on the flowering of a corn, of course it will be. But it is generally, the time of hydrolysis is not a limiting factor. How will you handle zinc source and dosage on a rotation of wheat, soy, and corn to cover the requirements of the soil? The first thing that you must do is to diagnose. You have to take a sample and you have to see whether you're below the threshold. And if you are, you need to apply zinc. It doesn't matter what the source is. Always apply zinc. If it's easy, it's better to go early in the sowing because it has the precursor such as hormone growth hormones. Within the sources in the market, there are a lot of sources to the seed, liquids or solids that go into the ground. Clearly, the dosage will go up. The lowest is to the seeds, then the ones that go on the foliage, and finally, the highest dose that I can apply that goes directly into the ground with blends that are chemical or physical. And once the seed is impregnated, it won't go into the soil because the dose is too low. But generally, unless I am in southeast Córdoba, with very low levels of zinc, then the zinc on the seed won't be enough. Generally, it is enough to cover or maximize the yield of that particular crop, but it won't allow me to build up the zinc in the ground. If I want to do that, generally, what's most appropriate is to use a liquid fertilizer with zinc or some physical blend or some chemical blend by applying 1 kilo or 1.5 kilos of zinc, which will allow me to build up zinc in the ground, because it has the same dynamics as phosphorus. What doesn't go on the grain stays in the system and will allow me to build up that level of zinc in the ground. And something else is that the dose that you should apply to modify that level of available zinc in the soil will depend on the soil. Once again, analogous to phosphorus. If you want to up your ppm of phosphorus, it's not the same on all soils. Although the levels for phosphorus have been studied in the Pampas, and if you will find that value in the bibliography, you won't find it for zinc. So if you want to build up zinc in the soil, it won't be the same in a soil with great capacity of absorption of zinc than in one that doesn't. And something else. If you want to build up zinc, apply more than you extract. And you can do that. According to the type of soil, you can do that. Okay. Nahuel is on the panel, and we have to ask something about the use of this data. Every how many years should I do this, and can I use it on all areas? My answer is that the code that you've scanned, go in there and you'll have all of the answers to these questions. But actually, you should measure it. It is an indicator of the weakest expressions of nitrogen. We say every 3-4 years, when you do a sampling to see the evolution of the soil when it comes to the health of the soil generally, you should check the level of Na. You have to monitor it always with the same care that you do for other nutrients, not only when it comes to sampling, but also the conditioning and the conservation of that sample until it reaches the lab. It's no good to get a sample and then put it in a fertilizer bag, and that has happened, or to put it and forget it for 15 days. Those are the things that you should do. The way we use it and whether we can use it everywhere. Actually, due to the southeast of Buenos Aires, when it comes to the use of in wheat, in sunflower, in potatoes, but we've done some approximations also with some theses in the core area, and there's been some work carried out in Córdoba in the north. There's also some in the northeast, in the University of Corrientes. So in each area, you should talk to the research centers that are nearby or Aapresid entities nearby, and you can get information. And if there isn't any information, if you go to Salta and you don't know what NaN is and you have to begin to understand mineralization, the easiest way to do it is by leaving a voluntary a corn witness, which gives me 12,000 kilos without nitrogen. That nitrogen was not fixated. Initially in the soil, it has 60 or 50 kilos. Most of that N came from mineralization. So the worst thing we can do is not pay attention to that mineralization. The indicators are in the yields, but as Nicolás was saying, the mineralization drops as time goes by. So our soil gives us less and allows us to build less yield in all of these different crops. So we need more N to close these yield gaps, more when it comes to fertilizer, to service crops, and to build up the organic matter. Pay attention to this and let us build up organic matter, which is the way to give nitrogen to the system. This is a question for Nicolás. I'm going to give you the mic because they want you to sing a song by Abel Pintos. Your turn.
No, digamos, eso lo hace también Nicolás, así como lo ven. No solo tiene...
He sings very well. Talk to me, I'm his manager. I forgot that you were going to be the manager, sorry. At the chat, we don't have any more questions. I don't know whether there's any questions in the auditorium. Everybody is exhausted. It's too much.
¿Estamos?
Bueno, quiere que cantes la llave de Abel. O sea que continuamos.
We continue on wanting you to sing.
Bueno, muchísimas.
Thank you very much, everyone. We thank them and we thank everybody for participating today.